Hello, I'm Papia. In today's problem, we are going to use limit process to find the area of a region. And the region is bounded by the function given by f of y is equal to 4 times y and the y-axis between y value 0 to 2. So you know that we use our basic limit process. We just find the area of a arbitrary rectangle and add all the areas and then take the limit. So we will do the exact same thing, but please be careful that now the function is defined in terms of y and its y-axis and y intervals. Okay, so let's understand this function first. So we are given the function f of y is 4y, which is x is equal to 4y. Now, you can see from this equation, this is a line. If you want, you can solve for y and see it even better. Y equals x over 4, so it's just a line, okay? So let's graph the line first. Remember, the interval is y value between 0 and 2, right? So this is between 0 and 2, but these are y values. So let's figure out the corresponding x values. So when y is 0, x is 0, so the line passes through 0, 0. And when y is 2, x is 4 times 2, so it's 8. So let's say y 1 and 2. So at 2, the value of x will be 8. So 1, 2, 3, 4, 5, 6, 7, 8. So approximately, this will be a point on the line. All right. Let's draw our line. All right, what is the region? Be careful. Look again, the region is bounded by this graph and the y-axis, not the x-axis, between 0 and 2. Therefore, this is the region that we are considering, okay? Now, what is our usual limit process? We first partition the interval, in this case the y interval, 0, 2, into n subintervals. And in doing so, we can actually figure out the width of each rectangle. Call it delta y, since this is happening on the y-axis. So what is the width? This is b minus a over n. N is unknown. B and a right here, 2 minus 0 over n. So the width of each rectangle or each subinterval will be 2 over n. So you just divide this interval into various subintervals and they are all of same width, right? And you consider drawing rectangles, right? Now, like when we use it for x-axis, we use the left or right endpoint. You can use anything, right? Any endpoints. In this case, you can use upper or lower endpoints. So let's say we want to use the upper endpoints of each one to find the length, right? So if you do use the upper endpoints, rectangles look like this, okay? So we have to figure out what are those y values that you will plug in the function to get the corresponding length of each rectangle. So we can use upper or lower. Let me use upper ones. Upper endpoints. So we have to figure out what those endpoints are. So we call them Ci. Now let's think about it. For the first one, for the first rectangle, what is the width? Well, of course, it's 2 over n. So C1 is 2 over n. What is C2? So you add 2 over n twice. C2 is 2 times 2 over n. What is C3? 3 times 2 over n. and so on. So what is Ci? I times 2 over n. Makes sense, right? So those are the endpoints that we will be using. And then once we have those endpoints, all we have to do is write down the limit definition that will give our area. Okay, so what is the area? Remember, we have to find the area of each rectangle, any arbitrary one. And area of a rectangle is length times width. Okay, so what is the length? Length is the Ci plugged in the function. Width is delta y right here. So that's the length times width. That's the area of one rectangle. So you add all of them, I from 1 to n, and then you take the limit as n approaches to infinity. So that will give us our exact area of the region. Okay, so let's plug in everything that we know. So we have the limit, we have the sum. Okay, f of Ci is right here. So this is f of 2I divided by n. And delta y is 2 over n. Okay. Next step, we figure out what is f of 2I over n. Look at the function. F of y is 4 times y. So f of 2I over n is 4 times 2I over n. Right? You just plug in that in the function, the 2I over n. And then we still have 2 over n. Okay, notice that this summation is over I. I is the variable here. So everything else is a constant. So n is also a constant inside the summation. So you can pull that outside the summation but inside the limit. So we'll do that in the next step. So let's see what constant we have. We have 4 times 2 times 2. So 8 times 2, that's 16. And then n squared divided by n squared. So you can pull that outside the sum. And the summation will be over just I. Just I remains. Okay, now think about what is the sum of I when I is 1 to n. We have a formula for that. Okay, so let's see. Summation of I equals 1 to n, is n times n plus 1 divided by 2. So now that we have a nice formula, we don't have the summation anymore. Now we just have to evaluate the limit as n approaches to infinity. Now notice that right here, n cancels with one of the n in the denominator, and the 2 and 16 also cancels. So 8 is a constant. You can pull it outside the limit. And inside the limit, we will have on the numerator n plus 1, since I pulled out the 8 already, divided by 1n. Okay, we can do one more step and then evaluate the limit. Notice that you are dividing these two terms, n and 1, by n. So you can divide them separately. So we will have n over n plus 1 over n. Okay. So n over n is 1 plus 1 over n. Notice as n approaches to infinity, 1 over n, this one approaches to 0. So this limit is just 1. So we have 8 times 1, which is 8. Hence, the area of this region bounded by the function 4y and the y-axis between 0 and 2 is 8. Thank you.